Nanotechnology is the science of manipulating matter at the atomic and molecular scale, typically within the range of 1 to 100 nanometers. To put this into perspective, a single nanometer is 1/1000th of a meter, about 100,000 times smaller than the width of a human hair. By operating at this nanoscale, scientists and engineers can create materials with extraordinary properties, transforming industries and reshaping our future. One of the most impactful contributions of nanotechnology to material sciences is in the development of stronger, lighter, and more durable materials. For example, carbon nanotubes, which are tiny cylindrical structures made of carbon atoms, are stronger than steel yet lighter than aluminum. These materials are already being used to reinforce sports equipment, aircraft, and even spacecraft, paving the way for more efficient designs. Another groundbreaking application is in self-cleaning and anti-corrosion surfaces. By mimicking the nanostructures found in nature, such as the lotus leaf, scientists have developed materials that repel water, dirt, and bacteria. These surfaces are being applied to windows, car windshields, and even fabrics, reducing maintenance and enhancing durability. Nanotechnology is also transforming electronics and computing. Nanoscale materials like graphene and quantum dots are enabling faster, more efficient transistors and memory storage devices. These advancements are critical as we push the limits of Moore's law and strive for smaller, more powerful electronic devices. In addition, nanotechnology is enabling the development of flexible and transparent electronics, opening doors to innovative products like foldable smartphones and wearable sensors. In the field of energy, nanotechnology is playing a key role in improving efficiency and sustainability. Nanostructured materials are being used to create more efficient solar panels, capable of capturing sunlight more effectively. Similarly, nanotechnology is enhancing the performance of batteries, enabling faster charging, longer-lasting energy storage, and lighter designs. These improvements are crucial for the widespread adoption of renewable energy technologies and electric vehicles. Nanotechnology's impact on healthcare and medicine is equally remarkable. In materials sciences, nanomaterials are being used to develop better drug delivery systems, ensuring that medication reaches its target in the body with minimal side effects. These advancements are particularly important for treating diseases like cancer, where precision is key. Additionally, nanotechnology is being used to create materials for artificial organs, bone implants, and tissue engineering, improving the quality of life for patients worldwide. One of the most exciting developments is in environmental applications. Nanotechnology is helping to create materials that can filter pollutants from water and air, address oil spills, and even clean up hazardous waste. By leveraging nanostructured membranes and catalysts, these innovations are contributing to a cleaner, more sustainable planet. Despite its immense potential, nanotechnology does come with challenges. Safety and ethical concerns must be addressed as we deploy these materials on a larger scale. Nanoparticles, due to their tiny size, can potentially interact with the human body and the environment in unforeseen ways. Scientists are actively researching these impacts to ensure that the benefits of nanotechnology outweigh any risks. In conclusion, nanotechnology is revolutionizing material sciences by enabling the creation of materials with properties that were once unimaginable. From stronger construction materials to advanced electronics and sustainable energy solutions, the potential applications are limitless. As research and innovation continue to accelerate, nanotechnology will play a pivotal role in shaping the future of industries and improving the quality of life across the globe.